Okay, we're going to be doing LeetCode 367, valid perfect square. You're given a positive integer called num. You're supposed to write a function which returns true if num is a perfect square, else false. So no using any inbuilt functions. So 16 is a perfect square because you multiply two integers to get it. 14 is not, right? You'd have to multiply an integer by a float or two floats. So this is a binary search problem because, for example, 16, any number that's a perfect square, that square root is always less than 16. It's always less than the number, right? So the square root, write it here. The square root of 16 is less than 16, right? For any number greater than 1, right? Then the other thing is, so that means we can find the number before the num value, right? So that means we can do a linear search from 1 till 15, right? Or till 16. We can check 16 as well if we want. But then instead of doing a linear scan, we can do a binary search, right? Because these numbers are going to be ordered, right? Obviously. So we'll start from 2 until num, right? We can start from 2 until num minus 1, but it doesn't matter, whichever you choose. But or you can even start from 1 if you want, in the event that num is 1, but I'm just going to handle that edge case where we don't even have to do any loops. So if num is equivalent to 1, we simply return true because 1 by times itself is 1. 0 times itself is also 0, but they said, that mathematical arguments for 0 being positive, but our constraint is that num will be from 1 to whatever this figure is. So the way we handle this is we use binary search and we create two pointers. So 0 and j is equal to num. So while I is less than or equal to j, our guess will be like a middle number, right? That's what we'll use for the guess, so that we get a binary search. So guess is equal to I plus, in brackets, j minus I divided by 2, and then we calculate the square root, which we'll call it square, is equal to guess times guess. Then we check. So if square is equivalent to num, then that means we found the square root. So we simply return true. Elif, we're going to use guess. Elif guess, okay, square actually, we use square. Elif square, I don't feel comfortable using square because the square may be larger. Okay, let's use square. Elif square, but even if you use guess, it will work. Elif square less than num, then that means that we want to discard all the numbers smaller than I, so I will equal to guess plus 1. Else, this means that square is larger than num, so we want to get rid of all the values before at j, or want to discard all those values, so guess minus 1. So if we iterate through all this and we still haven't found it, we return false. Voila, simple as that, right? So this is a log-n solution to finding the valid perfect square, right? So, all right, thank you, bye.